All right, really, this should be fairly simple. It's just we're using the trig derivatives and the chain rule. But then we have some restrictions, so I'm going to simplify and probably use this restriction. Just something that I noticed right away is, first, t is never bigger than 1, but it's never smaller than 0. It's actually never equal to 0 or equal to 1. That means it's always positive. T is always positive. Hopefully you can see that. And then I guess I mean you could think of it as a fraction or a decimal. So let's begin. So I will take the derivative y prime, and then secant, that's the one. So again, I'm trying to do it without looking. There, if you heard, I'm turning my sheet over. So what is that? Secant, that was that that was that third one there. It's one of the weird ones. So I would have 1 over the square root of the inside, right? You take the derivative of the outside, which is this, with the inside the same. So I have 1 over t there, times the square root of, well, sine has the 1 coming first, so that means this one has the x squared coming first, which is actually like parentheses squared minus 1. And inside those parentheses is 1 divided by t. And then, what else? So that's the derivative of the outside with the inside the same, times the derivative of the inside. And then the derivative of 1 over t is the natural log of t. And again, if I look at my interval, that's okay, right? I'm allowed to have that plugged in because t is never negative. T is never negative. It's actually never even bigger than 1. So this is okay because I'm not allowed to plug in zeros or negatives to natural logs. Who am I talking? I'm looking around. What? So what is that it? Yeah, kind of. I'm going to try and simplify. Wait a minute. I think I just made a mistake. I was thinking, yeah, it's this part. Some people might have thought like, wait, don't confuse me. I thought about this right after I wrote it. The derivative of 1 over t. If I wrote that as t to the negative 1, could I use the power rule on this? And I think I could. It would just be negative t to the negative 2, right? Yeah. That's something that I always check because I too get it confused with integrals and antiderivatives, I mean, as you just saw. So if ever you can use the power rule, use it, and that will help you like correct yourself, just like it helped me correct myself. So this is actually times, well, that's the eraser, times negative t to the negative 2, which is the same. Well, now I'm going to simplify. But first, let's think about this. First, this is always positive. T is always positive. So I really don't need the absolute values. Does that? Hopefully that makes sense. So y prime is actually equal to, let's say 1 over t times the square root of 1 over t squared. Hey. Well, that doesn't really do anything. Oh, yes, it does. That's a difference of squares. I don't know if I'll need that or not. But I'm just trying to simplify stuff. And this is actually negative 1 over t squared. So that's pretty sweet. This 1 is in the top of this fraction, and then the t squared is in the top of that, the top of the denominator. So actually, this cancels out with that. Sweet. So we have y prime equals negative 1, right, from the top, divided by, looks like just t, times the square root of 1 over t squared minus 1. And I bet I could do some little trickery stuff. So I'm going to show you a little trick. This doesn't happen in your homework assignment, but here's my little trick. If I have something outside a square root and I want to put it on the inside of the square root, I kind of have to make it so that it's the same value. So just notice that if I have t, that's the same thing as t squared under a square root, right? Right? So really what I'm going to do is I'm going to use this. So I'm going to use that substitution. This is a trick. This is something to remember. But hopefully it makes sense to you. It's just, if you've seen it before, then you can use it later. If you haven't seen it before, I mean, you might be able to come up with it, but I probably would never have come up with it. So I changed that, and then I have 1 over the t squared, and then a minus 1 on the inside there. And then now that I have square roots being multiplied, I can just write 1 square root. So I have negative 1 on the top again, and I have t squared, and it's all 1 square root. So I have 1 over t squared minus 1. And then I can distribute. So that's kind of cool. Later on, we will need to be able to simplify like this when we do trig sub, but I guess that's why I'm showing it to you now. So then we have what? We have just 1 minus t squared, which again is a difference of squares. That looks familiar. That looks almost like negative sign inverse. What? Oh, that's actually a property. I didn't even... We don't need to use that. But there we go. That's as simple as I think that I can make it. All right. Adios.